Hi, this is the Science Chef. Welcome to the third part of our series on the 2023 JAMB Preparations. We'll be continuing with our solutions to the 2017 UTME. In our last two series, we solved question 1 to question 10. If you'd like to watch the solution to those questions, you can check the link in the description. Today we'll be starting with question 11. Let's start. Question 11. During the electrolysis of a caustic potash solution using platinum electrodes, A. Alkalinity at the cathode increases. B. Potassium metal is deposited at the anode. C. Potassium metal is deposited at the cathode. D. Oxygen gas is given off at the cathode. This question is on electrolysis, and not just electrolysis, but electrolysis of common electrolytes. An electrolyte in this case is caustic potash solution. In our last video, in the second part of this series, we saw a question on electrolytes, and we defined what electrolytes are, right? So here, caustic potash solution is an electrolyte, and the electrolysis is carried out using platinum electrodes. And platinum electrodes, as we know, are inert electrodes. In other words, they do not partake in the electrolytic process. Now, this caustic potash solution, contains two electrolytes. Potassium hydroxide, which is a strong electrolyte containing what? Potassium ions and hydroxide ions. And water. Of course, water, we know that water is a weak electrolyte, so it undergoes partial ionization to give us H+, hydrogen ions and hydroxide ions. So the three ions present in this electrolytic solution are potassium ions, hydrogen ions, and hydroxide ions. So the potassium and hydrogen ions, being positively charged, will migrate to the cathode, which is negatively charged, and the hydroxide ion, being negatively charged, will migrate to the anode, which is positively charged. Remember, this is electrolysis, so we are using an electrolytic cell and not an electrochemical cell. In an electrolytic cell, the anode is positively charged while the cathode is negatively charged. So at the anode, or let's start, yes, at the anode, what happens? This guy is what? The preferentially discharged, because there's no competition for hydroxide ion. So the hydroxide ion undergoes oxidation to form water and oxygen in the ratio, this ratio 4:4:1. 4 moles of hydroxide ions will lose 4 moles of electrons to form 2 moles of water and 1 mole of oxygen gas. Whereas at the cathode, the potassium and hydrogen ions will migrate to the cathode, and the hydrogen ion will be preferentially what? Discharged, due to its what? Lower reactivity in the electrochemical series. So it undergoes reduction to form hydrogen what? Gas. Fine. We are not going to go into too much details on this. We are going to stop here based on the question that we are being asked. Now let's come back to the options. We are told that alkalinity at the cathode increases. That's A. Well, we don't know yet. Let's look at options B. Potassium metal is deposited at the anode. Is it possible? No. Potassium anode can never be deposited at the anode, because the anode is positively charged, and the potassium ion is also positively charged. So there's no way the potassium ion can migrate to the anode. So option B is out completely. Let's cross that. Right? Then potassium metal is deposited at the cathode. Is it possible? Yes. There's a possibility of potassium ion being deposited at the cathode. But is that the case? Is that what happened? No. Hydrogen ion was discharged at the cathode because there was a competition between the hydrogen ions and potassium ions. But because potassium ions is higher in the electrochemical series than hydrogen ions is more preferentially discharged than potassium ions. So potassium metal can never be deposited at the cathode in the presence of hydrogen ions. If you want to watch our video on the factors that affect the preferential discharge of ions during electrolysis, check the link in the description. Then oxygen gas is given off at the cathode. Is it possible? No, because oxygen gas can only be produced from the discharge of hydroxide ion. And from the analysis here, hydroxide ion is discharged at the anode. So there's no way oxygen gas can be discharged at the cathode. The fact is that apart from hydrogen gas, any other product at the cathode is always a metal, it's always a solid, because the cathode is where you have the cation ions. And apart from hydrogen ion, which is the only non-metallic cation in the electrochemical series, every other cation there is metallic, right? Every other cation is metallic, of course, apart from ammonium ion, but ammonium is not part of the electrochemical series considered in this case, right? So, which means that apart from hydrogen gas, which is the only gas that can be liberated at the cathode, any other product at the cathode is a metal. And being metals, the product will be what? Solid. Fine. So option D is also out, leaving us with option A. But how can we explain that alkalinity at the cathode increases? Okay, let's see. At the cathode, we've confirmed that hydrogen gas is liberated, is it not? Great. So if hydrogen gas is liberated, what do you think will happen to this equilibrium reaction between water and hydrogen ions and hydroxide ions? What will happen? If hydrogen gas is liberated, remember, for hydrogen gas to be liberated, hydrogen ions will have to be removed. So if hydrogen ions is removed from the solution as hydrogen gas, what do you think will happen? The equilibrium position will shift to the right, and if equilibrium position shifts to the right, what will happen? More hydroxide ions will be produced, right? And if more hydroxide ions are produced, right, due to the removal of hydrogen ions at the cathode, what do you think will happen to the alkalinity, right? What do you think will happen to the alkalinity? The alkalinity will do what? Increase, because hydroxide ions are responsible for the alkalinity of any substance, just like hydrogen ions are responsible for the acidity of any substance. So at least that explains why A is correct. So the answer is A. Question 12. Which among these has neither charge or mass? Okay. A, alpha particle, B, deuterium, C, gamma ray, and D, neutron. Okay, let's analyze. Alpha particle. Alpha particle is represented by the helium nucleus. Helium nucleus, which has a charge of +2 and a mass of 4. This is the helium nucleus, charge of +2 and a mass of 4. This is the alpha particle. Alpha particle, right? Why is it represented by the helium nucleus and not the helium atom? The helium atom is neutral because the helium atom will have 2 electrons and 2 protons. Because it has 2 electrons and 2 protons, so its overall charge is 0. But the alpha particles are positively charged, and because they are positively charged, the nucleus contains only protons, which is why it's represented as the helium nucleus, because it has a charge of +2, or the helium nucleus contains 2 protons. Contains 2 protons and of course 2 neutrons. But you know that the neutrons have no charge, so that is why the alpha particle is represented as the helium nucleus. So the alpha particle has a charge and a mass, right? So it can be alpha particle. Let's cross it out. Deuterium. Deuterium is the isotope of hydrogen. Hydrogen has 3 isotopes: hydrogen 1, hydrogen 2, and hydrogen 3. Hydrogen 1 is known as protium. Protium, or what we call ordinary hydrogen, which is the common hydrogen that we know, right? Hydrogen 2 is the deuterium. Deuterium, found in what we call heavy water, D2O, while hydrogen 3 is tritium. Tritium, which is radioactive, so it's very rare and otherwise unstable. So then this deuterium here is used in nuclear reactors. That's equivalent. So, but the question is, which among these has neither charge nor mass? So does deuterium have a charge or a mass? So let's see. Deuterium. So the full representation of deuterium is H21, right? And this is the charge, because it means that it has one proton, which is +1, means that the charge is +1, and it has a mass of 2. Gamma rays, unlike alpha and beta, is not a particle, rather it is an electromagnetic wave, right? And because it's an electromagnetic wave, it has no charge and no mass, and it is represented thus. That is gamma, or at times we represent it as this. So that's gamma. So it has no charge, that's no mass, right? I think gamma is likely going to be the answer, but let's confirm with from the last option, right? Remember, like I always advise you, don't just rush to pick any answer in JAMB, because JAMB has a way of making two answers look very similar. So take time and go through all the options first before picking the right answer, and you must have been convinced that whether option is the correct answer. D, neutron. Fine, neutron is also a subatomic particle that has a mass of 1 and a charge of 0, because a neutron is found in the nucleus of an atom, right? And being found in the nucleus of an atom, it only adds to the mass of the atom, but has no effect on the charge of the atom, right? It is only the protons and electrons that are responsible for the charge of an atom, right? While the proton and the neutron are responsible for the mass of the atom. So it cannot be neutron, because neutron in this case has a mass, though it has no charge. So the answer is definitely gamma ray. So let's select that, gamma ray. Question 13. The minimum amount of energy that colliding molecules must reach or possess for their collisions to be successful is known as A, thermal energy, B, collision energy, C, activation energy, D, kinetic energy. Actually, there's no need wasting time on this question. There are some questions you're not meant to waste your time on. The answer to this question is activation energy, right? So activation energy, otherwise known as the energy barrier of a chemical reaction, is the minimum amount of energy that the colliding particles must reach or must possess before any reaction can occur, right? So that's why they are told that for their collisions to be successful. That's why once their collisions are successful, it means that a reaction has occurred. So the reactant particles or reactant molecules must overcome the activation energy of that reaction. The energy of the reactant particles or molecules must be greater than or equal to the activation energy of that reaction before any reaction can occur. Now, for that to happen, they will have to collide. They will have to collide, and as they collide, they acquire more energy, and that comes from an increase in kinetic energy. So the continuous collision will give them more energy to overcome the activation energy. However, it is not all the collisions that will always result in the formation of products. Rather, it's just a fraction of the millions of collisions that will result in the formation of a product, and that fraction of collisions that result in the formation of products is always called or is known as effective collisions. Yes, so those are the collisions that lead to the formation of products, right? So which means that for a reaction to occur, there are three conditions that must be met. The three conditions that must be satisfied for a reaction to occur are: 1, there must be effective collisions, which are collisions that lead to the formation of products. 2, the activation energy. The particles must acquire a minimum energy that is greater than or equal to the activation energy of the reaction. And 3, there must be proper alignment. These three conditions must be satisfied before a reaction can occur. What do I mean by proper alignment? Let's say hydrogen is reacting with iodine. Hydrogen molecule is reacting with iodine molecule to form hydrogen iodide, right? If hydrogen molecule is aligned this way and the iodide molecule is aligned this way, there's no way it will lead to the formation of a product. It's not possible. That is an improper alignment, right? For there to be formation of products, the hydrogen molecule must align properly with the iodide molecule, right? With this, now you can have effective collision. So these two will collide, right? And as they collide, a new bond will be formed here, while this one will be broken. So we now end up having something like this as an intermediate. Which now gives us 2 molecules of hydrogen iodide, right? So this is the stage, the intermediate stage, at which the bond breaking and bond formation occurs, right? That's this transition stage or transition state where bond breaking and bond formation occurs. That is the state at which the activation energy is overcome. That's where the product formation start. But once that is attained, then you will get your your product formed. But for that to happen, there must be a proper alignment. There will be effective collisions, and the result of effective collisions will lead to overcoming the overactivation energy. So our answer here is question 14. Which among these is generated during the manufacturing of fertilizers? Which among these is generated during the manufacturing of fertilizers? A. Hydrogen sulfide, B. Carbon 4 oxide, C. Sulfur 6 oxide, and D. Lead. There are two major compounds or chemicals, right, that are very important in the manufacture of fertilizers. One is ammonia, while two is H2SO4, tetraoxosulfate 6 acid. Now, ammonia is obtained from nitrogen and hydrogen gases, right, from the Haber process, while tetraoxosulfate 6 acid is obtained from the contact process, starting with sulfur, burning of sulfur in oxygen to form sulfur 4 oxide, right? So in the process of forming sulfur 4 oxide, further procedures are for the sulfur 4 oxide is then converted to sulfur 6 oxide in the presence of vanadium 5 oxide as a catalyst at 450 degrees Celsius, right, and 1 to 3 atm. And after that, the sulfur 6 oxide, that's the SO3, is first of all dissolved in a little amount of H2SO4 to form oleum, and the oleum H2S2O7 is then dissolved in water to form a concentrated H2SO4. So the question is, which of these is generated during the manufacture of fertilizers? Of course, since we are going to use H2SO4 to make fertilizer, right, we are going to react ammonia and H2SO4 to form our fertilizer. To get our H2SO4, we must first of all generate sulfur 6 oxide. So the answer to that question is sulfur 6 oxide. C. Question 15. What is the empirical formula of an organic compound containing 40.1% of carbon and 6.6% of hydrogen? We are given the relative atomic masses of carbon, hydrogen, and oxygen. Now we look at this question, you find out that the percentage composition of the elements given to you do not add up to 100%, right? It means that there's something missing, and you are given 3 elements, carbon, hydrogen, and oxygen. It means that the balance should be oxygen. So we have 3 of them here, carbon, hydrogen, and oxygen. Carbon here, percentage composition is 40.1, hydrogen is 6.6, while oxygen is so that's oxygen will be 100 minus 40.1 plus 6.6. 40.1 plus 6.6 is 46.7. 100 minus 41.1 plus 6.6 is 53.3. So while carbon is 40.1%, hydrogen is 6.6%, and oxygen is 53.3%. If you add up everything here, you get 100%. Fine. So the next thing is to divide this percentage composition by the relative atomic masses of the elements involved. Carbon is 12, hydrogen is 1, while oxygen is 16. 40.1 divided by 12 gives us 3.3. 3.3. 6.6 divided by 1 gives us 6.6. While 53.3 divided by 16 gives us 3.3. So this is the number of moles. So after that, we now divide through by the lowest number of moles. That's 3.3 over 3.3, 6.6 over 6.6 over 3.3, sorry, and 3.3 over 3.3. So this gives us 1, 2, 1. So the empirical formula of this compound will be carbon, 1 carbon atom, 2 hydrogen atoms, and 1 oxygen atom. That's the ratio of carbon, hydrogen to oxygen will be 1:2:1, and the answer there is that should be C. That's C. What's the value of X in FeNH42SO42.XH2O if the molar mass of X is 392 grams per mole? Now the truth about this kind of question is, if you see a question like this, don't waste your time trying to solve this, because you are working against time. Are we together? JAMB is speed and accuracy. So if you have a question like this, what I will advise you to do, skip this question and go to the next question, right? Try to answer the easier question that will not waste your time. Then after you are done with that, you come back to question that will demand more time from you, right? So it's just because we are practicing here. That's why I can afford to spend time solving this. Okay, we're looking for X, right? Okay, so we have Fe, NH4, 2, and SO4, 2. This is a double salt, and H2O, right? If the molar mass is 392 grams per mole, good. So to get the molar mass, yes, we already know the molar mass of the compound. So what we are going to do is to try to add up everything here and then equate it to the molar mass, right? And from there we find the word unknown. So here we have Fe plus, I'm going to be fast here, I won't spend much time doing this. So what I'll do is, okay, iron is 56, so I'm going to do Fe here plus 2NH4, that's what I will do, plus 2SO4 plus XH2O, giving us what? 392, right? Iron is 56, so that's 56 plus, nitrogen is 14, hydrogen is 1. 1 times 4, 4. 4 plus 14, that is 18. 18 times 2, that's 36. Plus oxygen is 16, sulfur is 32. 16 times 4 is 64. 64 plus 32, that's 96. 96 times 2, that's 192. Plus hydrogen is 1, oxygen is 16. 1 times 2, 2. 2 plus 16. We have 18x, giving us what? 392. 18x equals to what? Which gives us 108. So our x will be what? 108 over what? 18, which gives us 6. So the answer is what? D. But there are certain things that you must master, like the molecular mass of H2SO4 is what? 98. You don't need to waste your time calculating it. CaCO3 is 100, right? So when you see things like this in a question, just apply this immediately and move, because there's no time. All right, so the answer is D, which is 6. Question 17. What is the percentage composition of oxygen in K2Cl2O7? To calculate percentage composition, we use the total mass of the element in the compound divided by the molecular formula of the word compound times 100, right? There are 7 atoms of oxygen in K2Cl2O7, potassium heptazodichromate, what? 6. So we have 7 times what? 16 all over the molecular mass of K2Cl2O7. Okay, you are given 290, good, 294. Okay, 7 times 16 is what? 112 over what? 294 times 100. This gives us 38.09% or 38.1%. Okay, and the answer here is what? D. Question 18. Consider the reaction 2Al solid plus 6 hydrogen ions, giving us 2 aluminum ions plus 3 hydrogen gas, 3 moles of hydrogen gas. Now, what is the total number of moles of electrons transferred from the aluminum atoms to the hydrogen ions? Now, given that this is a balanced ionic equation, you don't have to calculate the total number of moles of electrons transferred. Just calculate the charges. Calculate the charges on the left hand side and on the right hand side, right? Not in all cases, but it only applies for simple ionic equations like this, not complex ionic equations, right? On the right hand side here, we have 6 times plus 1. We have 0 for aluminum, and hydrogen 6 times plus 1, that's plus 1, plus 6, sorry. And here we have 2 times plus 3, that's plus 6, and hydrogen plus 0. So we have plus 6 and plus 6, means that 6 moles of electrons were actually what? Transferred. How was that achieved? If you break this up into half equations, we have aluminum giving us what? Undergoing oxidation to give us aluminum ions. It loses 3 electrons to form aluminum ion, while hydrogen gains an electron to become hydrogen what? Gas. And because the hydrogen gas, we balance this. This will be 2 and this will be what? 2, right? But the number of electrons lost must be equal to the numbers of electrons gained, right? So since there are 3 electrons lost here and 3 electrons gained here, we multiply this by 2 and this by what? 3. So this gives us what? 2, 2 and what? 6. Well, this one will be what? 6, 6 and 3. So we add up both of them. So what do we have? We have 6 moles. You can see that there are 6 moles of electrons lost and what? Gained. So this will cancel out, right? So we are now left with 2 aluminum solid plus 6 hydrogen ions, giving us what? 2 aluminum ions plus 3 hydrogen gas. Okay, so that's how we obtain what? The 6. If you want to learn more about balancing of ionic equations or balancing of redox equation, watch our videos on redox equations. We have added the link in the description. So the answer here is D, 6, right? Okay. Question 19. Metals can be extracted from their ores by a process involving A, reduction, B, oxidation, C, hydrolysis, and D, decomposition. Actually, the extraction of metals involves reduction. So because we are separating a metal from its what? Compound. Let's say sodium. Now we want to extract sodium from sodium chloride. So we are trying to change the oxidation state of sodium from +1 to 0, right? This is -1 and this one is 0. So from +1 to 0, that's what? A reduction. That is a reduction, and that is what extraction of metals is all about, right? Extraction of metals is a process that involves reduction, and there are different methods of extracting metals. We have the electrolytic reduction for the highly reactive metals like potassium, sodium, calcium, magnesium, and aluminium. Then we have the chemical reduction. We have the chemical reduction for the moderately reactive what? Metals, using what? Carbon as the reducing agent, either carbon or carbon 2 oxide as the reducing agent. You can extract metals like zinc, iron, tin, lead, etc. using reducing agents. You can extract these metals from their ores, right? Then lastly, can you have what? Thermal reduction, which involves just heating the oxide of the metal, like mercury 2 oxide, heating mercury 2 oxide to obtain mercury and oxygen, right, without using any reducing what? Agent. You can see that you go down the activity series, the method of reduction becomes what? Easier, right? Because the energy required to break the bond between the metal and the non-metal becomes what? Lower, right? It's reduced. The strength of the energy is what? Reduced. So less amount of heat or energy is required, right? You can see the very reactive metals require the most expensive method of reduction, which is electrolytic what? Reduction, while the least reactive metals require the least expensive method of extraction, which is thermal reduction, right? So the answer here is what? A. It is not oxidation, because oxidation is the increase in oxidation number. As you can see in this reaction, the oxidation number of sodium is not increasing, rather it is what? Decreasing. It is the oxidation number of the chlorine atom that is what? Increasing from -1 to 0, so it cannot be oxidation. Then hydrolysis. Hydrolysis has to do with using water to break a compound into 2 different parts. So since we are not applying water here to break this compound into 2 parts, it cannot be what? Hydrolysis. And then decomposition. Decomposition is a reaction that involves the splitting of a reactant into 2 or more what? Products. If you want to learn more about decomposition, right, you can watch our video on the types of what? Chemical reactions. We have added the link in the description. So the answer to this question is reduction. Also, for your help, please ensure you watch our videos on extraction of metals and their compounds. We have a video on extraction of aluminium, extraction of iron, and properties of aluminium. Ensure you watch those videos. We have added the links in the description. So our answer is what? A, reduction. And our last question for today, question 20. The solubility of alkanols in water is due to A, its density, B, the presence of hydroxyl groups, C, its low freezing point, D, its volatile nature. Alcohols are organic compounds with general molecular formula CnH2n plus 1 OH, where OH is their word functional group. That's the hydroxyl group. Because of the presence of this hydroxyl group, they can form what we call what? Hydrogen bonding with themselves, just like water. So how do they form the hydrogen bond? Because of the polarity in the hydrogen-oxygen bond, right? The oxygen atom tends to pull the two electrons, the electron density used in forming the bond between it and hydrogen atom towards itself, thereby making itself partially electron surplus and the hydrogen atom partial electron deficient. Then when it now comes in contact with water molecules that also has the hydroxide ion, or the OH bond, negative, positive. So the positive end of the hydroxyl group in the alcohol will be attracted to the negative end of the water molecule, right? Through an electrostatic force, which is known as the hydrogen bond. While the negative end of the hydroxyl group in the alcohol molecule will also be attracted to the positive end of the water molecule through the same electrostatic bond, which is the hydrogen bonds, right? This hydrogen bond allows the interaction of the polar ends of the alcohols with water molecules, right? And because of that, it accounts for the solubility of alcohols in water, right? And not just accounts for the solubility of the alcohols in water, it accounts for the high solubility of the alcohols in water, though that solubility in water decreases as this alkyl group increases, as the alkyl, or the number of carbon atoms in the alkanol or alcohol molecule increases. The solubility would decrease, right? And the solubility also increases if the number of hydroxyl groups in the alcohol also increase, which is why a diol will be more soluble in water than a monohydric alcohol. A diol is an alcohol that has two hydroxyl groups, like ethane diol, CH2CH2OH, right? Ethane diol will be more soluble in water than ethanol, C2H5OH, because it has two hydroxyl groups in water than ethanol. Then the hydrogen bonding is also responsible for the high boiling point of alkanols, because it allows the alkanol molecules to bond with themselves strongly. Now, the hydrogen bond is formed when hydrogen atom is covalently bonded to any of oxygen, nitrogen, and fluorine. When hydrogen atom covalently bonded to either of oxygen, nitrogen, and fluorine is now bonding with any of these other atoms in another molecule, as we have seen here. So the answer to this question is what? B, the presence of hydroxyl group. It cannot be low freezing point, right? Neither can it be density or volatile nature. That is also the end of our tutorial for today. If I learned anything from this lesson, kindly drop a comment. And if this is your first time here, ensure you subscribe to this channel. Also turn on your notification bell. From our next tutorial, we'll be solving questions on topical basis. In short, specifically, we'll be solving JAMB questions on organic chemistry. After that, we'll move to another topic. So in order not to miss that opportunity when the question will be uploaded, endeavor to subscribe and turn on your notification bell. Until then, keep doing what you know how to do best. Until I see you, when I'll see you.